Now we're going to come to perhaps one of the trickier concepts in SQL and in databases, and that is querying data from across multiple tables. We're going to examine why do we have multiple tables? Why not just take a series of information and just shove it all in one table and just query that one table? Well, there's actually very good reasons for it, and we'll examine those. We'll talk about how we take those multiple tables and how we bring them together in the concept of foreign keys. And we'll talk about the ways in which you can join tables, the right ways and the not so right ways. Well, let's look at a practical example of two tables that have related data that is spread across two tables, and we'll look at the structure of it and get an idea of what's actually going on. So if we go down here, we see a table called production.productModel, and let's just query the whole table and see what's in there. Okay, what do we got? We got a product model that appears to be a prime key, and we've got a name. Looking down here, for example, we've got Mountain 300, obviously. This AdventureWorks database is depicting a bicycle manufacturing company, so that's some kind of a mountain bike model number 300. Now, if we go up to good old table production.product, let's have a look in that. If we scroll down and we open up the objects, if we open up the columns, if we look down to, we have got a product model ID. Now that column is a little bit special. You may have noticed that it has a little key symbol next to it that looks a bit different to the prime key symbol we've seen before. That's because it is a foreign key. That probably sounds a little bit scary, but we're going to explain it quite easily. We also know it's a foreign key because in its little definition there, it has that little initials FK, which stands for foreign key. Now, what does foreign key stand for? Now, let's just query the entire table and look at it a bit closer. You can have multiple query windows open. So to do that, let's just hit New Query, and we'll have a second window open, and we'll query product again. Okay, there's good old product ID. There's the name of the product. And basically, the way it works is the product is a specific implementation or version of the model. So each product has a model. The product is linked to the model by virtue of that foreign key field, that horrible word I mentioned before, called product model ID. I'll just go down here to ones that actually do have a model. Now, what that represents, those little numbers, they represent prime keys from the model table. So every value that you see here under product model ID and product can actually be found here. That's how the two are linked. So for example, if I were to scroll down to find a product with product model ID 21, in fact, let's just scroll down and see if we can find one. Oh, there we go. Right, there's one. So I'll just go over to the far left and look at its product name, Mountain 300 Black 38. So it's a Mountain 300 bike, but this particular product is black and it's size 38. But thanks to that foreign key there of 21 in product model ID, we know that its model is of name Mountain 300. Now you're probably wondering, why do we have this data spread across two tables? Well, let's just look at the data that is within product model. Now, we need to retain the product model information. We need to know the name. Obviously, a customer is going to buy this product. They need to know what model it is so they can get some basic information about the product. So we need to know, with respect to that product, what is its model. So you're probably wondering, that Mountain 300 name for the model, why don't we simply just store it on the product table? Instead of having this funny product model ID number here and linked to a separate table, why don't we just have a model name here and just put there the actual model name, Mountain 300? In fact, there's a few products there that are linked to the same model. Why don't we just simply have that product model name there, and there, and instead of having a separate table? Why make life hard for ourselves with multiple tables? Well, part of the answer is, when we look at the product model table, it not only has a name, but it's got two other critical pieces of information as well, the catalog description and the instructions. Well, I'll talk about two of the main reasons why we sequester, if you like, a data like model off onto its own table and have this key linkage thing going on. Let's see what would happen if we actually took the model data and we just simply put it on the product table. So our Mountain 300 bike product records would look like this. You'd have the product key, the name, and the model catalog and the model instructions would all be stored right there. Now, what if the company put a mandate that the catalog name for model Mountain 300 was to be changed from mountain bikes to, oh, I don't know, mountain bicycles? Now, when you've got that data in its own table, you would only have to do that once, but with this data scattered across all these product records, you've actually got to update it many times, and you could be talking thousands of times. So it's a slightly inefficient way of doing that from an update point of view. Now, the other reason is for a sort of data consistency reason. Let's say, for example, we wanted to do a report of all bicycle products of model name Mountain 300. Now, let's say that when they were entering this particular product, someone made a spelling error in the model name and they happened to put a space there. Or let's say on this one down here, they happened to put a space there after the hyphen. You're seeing some inconsistency. We are dependent on that model name being the same for all those product records if we are going to get all those models of products gathered up into one report. So by having this just plain free text, there's a danger that there is going to be data inconsistency and the data linkage between model and product will be lost. So now we're looking at the arrangement where the model information is stored away on its own little table. It's got a key, and that key is what is stored against the products, not all this bit of information here. So as you can see, if we wanted to update some information about the model, say change the name from bike to bicycle, we only have to do it once. It's done once on one record here in the model table instead of hundreds, perhaps thousands of times on the product table, and there is less chance of data entry error. The other benefit is a thing called referential integrity. Now, when we set up a foreign key, and this is what this is, this model ID, it's a foreign key, there's that word again, it comes with a thing called referential integrity, and that means that any value here must already exist here in the model table. If, for example, we were to change that model ID on that product 785 to 32, and there was no 32 in the model table, that would not work. That would throw an error. Now, that's to do with database design, and which of course is outside this course. We're just showing you how and why we have this arrangement of data across different tables. With that arrangement of the model data normalized is the word, normalized, into its own table and joined by a key there and a foreign key there, we can say with absolute certainty that if we want to query the product table for all Mountain 300 models, all we've got to do is go select star from product table where model ID equals 31, and we know absolutely that these guys we select will have a product name of that and a model catalog of that. But coming back to our product table, let's say we have an objective that we've got a product and we want to find out the name of the model of this particular product. Now, if we're browsing, let's say we know about the product table and we've gone and selected all the columns and we're looking across here and we're looking at the model ID, but that doesn't tell us the model name. We've got two issues here. How do we find out where that product model information is stored, and how do we link this product record to it? Well, as discussed, all these sorts of answers can be obtained by looking at the data dictionary for the system that we are reporting on. Now, in this case, we've got the data dictionary for the products schema within the database, and this is what a database dictionary diagram looks like. There is more text details later on in this document, but this is the diagram for the AdventureWorks database, specifically the products schema. And if we look down here, we've got our product table. It lists the key and a couple of columns. And over here, we've got another table, a square representation of the product model. And we've got a line drawing the product model table with product. The line goes down here, and we've got this funny sort of three-pronged crow's feet symbol here, and that signifies it is a one-to-many relationship. A one-to-many relationship, what that means is for every one key here, there may be many of them over here in the actual product table. Now we need to know about this stuff because that will affect how we design our query. So let's look at the table and at an example, a physical example of this one-to-many relationship. So this is what one-to-many looks like. Here is our query for product model. There's our product model record, 21. That's the prime key. There's only one of them. There's only one prime key and there's only one model, which is the whole purpose of having this table. So take note of that key there, 21. And if we go to the product table and we look at our Mountain 300 products, there's 3 of them there. If we go across to the product model, there is the 21 code, and that represents that model we were looking at, but you can see there's many of them. So that describes the relationship. You've got one record for model, but there will be many instances of it in the product table, and that relationship of one there and many links to it there, that is what this diagram represents. Now that's important, sounds technical. Again, this is database design, and the more going further into that is outside the scope of this course, but we need to know about this when we go to design our query. That will become apparent. Now if we scroll down further into the data dictionary, we've got an actual full-on proper definition of the product table. Unfortunately, it's sort of split across 2 pages here, but not to worry. If we scroll down, there is a list of all the columns and descriptions such as the data types and a bit of a description there of each column, the first of which is the product ID, the prime key. But if we go down to product model ID, it tells us the data type, and it tells us product is a member of this product model. Foreign key to product model.product model ID. So that is telling us product model is the table name, and that is the prime key in the model table, so that links to that. So now we have enough information to start writing our query to join the 2 tables. Well, I've always thought that the best way to learn something is just to jump in and do it. So what I'm going to do is I'm going to write the query to join the 2 tables, and then we'll discuss it. Okay, with that, now I'm going to execute that, and we will just very quickly examine the results. Okay, what's happened? Well, some funny things here. The order has suddenly changed. There was the product ID number 1 was at the top, but we've got this weird looking order here. But let's look at the columns. Product ID, name, they're the names of our product columns. But if we scroll over to the right, keep scrolling, keep going. Oh, look at that. We've got a whole bunch of columns from the product model table. There's ID, there's name, catalog, instructions, so on and so forth. So what we've done is we have joined the 2 tables, product and product model, and by virtue of having the asterisk there, that selects not just all the columns from product, but all the columns from product model as well. Now, that's looking pretty convoluted, and it's going to be hard for me to demonstrate what's physically happening to the results there. So I'm just going to select a couple of them. So I'm going to select to start off. I'm going to select product ID, and we're going to select name. So let's just see what happens here. Oh dear, what's happened? We've got an error. Ambiguous column name, name. Now, what does that mean? Well, I'll explain what that means, and it's to do with something that I've mentioned very early in the course about having aliases for the tables. Now, I'll put things back the way they were. I'm going to Control Z my way out of this. Okay, so we've put everything back. We've got the asterisk up the top there. So before I execute that, let's just make a mental note about this error, ambiguous column name, name, and then we'll talk about what that means and why it's ambiguous. But what I'm going to show you is there is a reason that I've been telling you to put aliases on your table names, because we're going to use these aliases in the select clause in a minute, and you're about to find out why. So I'm just going to go back and select it with star in the select clause. What have we got? Okay, now this is the product table, product ID, name from the product table. But if we go over here, In our results, we've also got a second column called name that came from the product model table. Now that's what the error means, ambiguous column name name. So when I went name up the top here, SQL Server doesn't know, do you mean the product name or do you mean the model name? I don't know. So how do we fix this? Well, we've got to actually tell, when we select name, we've got to tell SQL Server which of the two tables, product or product model, is the name column that we want. Now we want product. Now how do we do that? Well, so far up until now throughout the course, we've just been typing in column names as such, but there's another way to type them, is that you can actually explicitly tell SQL Server what is the table name that it comes from, like so. So I've taken my table alias, PP, and I've put it up the top there. Now let's see what happens. Great, that's a bit better. That's actually worked. And you know what? I'm going to put another column up there, product ID. Again, I'm going to prefix it with the PP table alias. And there we go. So what did I do? I prefixed my column names with table names. Now, up until now, we've been able to get away without table prefixes because we were only querying one table. And within one table, you can only have, each column has to have its own individual special name. You can't have duplicate names. So this ambiguity of column names was never an issue. But when you're joining two tables, and those tables may have columns the same name, you have to explicitly tell SQL Server where the table name comes from. Even if you are only querying one table, it is considered good practice to prefix your columns with the table name. Now, up until now, I've kind of been letting you get away with not doing it because it was legal when you're only doing one table. But as a matter of course, it's generally always good practice to prefix your column names with the table name. So let's continue our query and then we'll discuss it. Okay, what have we got? We've got some columns from something from column A and something from column B. Again, sounds a bit like a Chinese menu. But what we've got is some columns from the product table and some columns from the product model table. Product ID, name, that is the model ID from the product table. We can see it up there. And that is the model ID from the product model table. Now you can see what's happening is that the two are the same. So what's happening is the SQL Server has gone to the product record, it's looked at model ID, and then it goes over to the product model table, takes that value, tries to match it with the product model ID key, prime key column in that table, gets to that record, and then obtains this column value from it. So let's analyze the statement that we wrote to query those two tables. Well, it began with a select clause. So we had a from clause. We selected from table 1, and then we had another bit of text that was the join command. We had the join type. Now, I'll come to what join types are possible. So it was table 1, a type of join. In our case, it was inner join. And then the second table that you were joining to. And then the word on, and then the condition that you are joining on. In our case, now that condition has to be one of those where type conditions, something equals something that's got to be evaluated to true or false. So it's usually something equals something, and it's usually one key equals another key, usually a prime key equals a foreign key, usually. So let's go through a brief summary of the join types that can go into that from clause that we saw in the previous slide, and then we'll go into in-depth discussion about each of the types. So the types are inner join. An inner join means both tables must match the condition if a row from that table is to be returned. A left join, all of the left-hand table gets returned, all of them regardless. If you've got 100 rows in the left table physically, all 100 get returned, but only data from the right-hand table gets returned if it matches. And a right-hand join means all the records from the right-hand table get returned, and only data from the left-hand table get returned if it matches. That's all going to make more sense if we look at some examples. So here we've got a diagrammatic representation of the two tables we've been working with, the product table and the model table. In the product table here we've got 3 records. 2 of them are linked to model 20, one's linked to model 21, one has no model at all. And in the model table, we've got a 20, a 21, and we've got a 23 here. And that 23 is a model that actually does not exist in the product table at all. So when we do an inner join, how do things match up and what is the result? Well, the matching happens like this. This product has a 20 that matches with that model. That has a 20 that matches with that model. That has a 21 that matches with that model. That does not have a model and it matches with nothing. So that's not going to get returned in the data. This model does not have a value in the product model. It is not linked to the product table at all. So that's not going to get returned at all. So what is the actual result of the join in the final data? Well, we've got 3 rows. So it's kind of a product of the matching. It's these 3 products that have a value in model table. The one that did not have a value didn't get returned at all. And the model row that didn't have a model in the product table, that didn't get returned at all either. So it's kind of a narrowest combination of the 2 tables. Now the key concept to get right here is you may be wondering, if we go back up to the raw data, you may have wondered, well, how does this get represented within a grid if this is a match, and this is a match, but this isn't? How does this get represented in a grid of both this and this? Well, as you can see, the 20 record, because that matches twice, that gets repeated. That is on 2 rows. And if we go down to the results, that's what we see. The 20 row, the 20 model row, is repeated. And it has to be repeated in order to match with these 2 products so that it forms a grid in the results. So let's see an inner join in action by querying our actual database. So I've got 3 query windows open. The first one selects everything from product.sql, and I've taken the liberty of putting the foreign key product model ID in the leftmost column so we can see it. And if we scroll down, we can see that if we go right down the bottom, we can see there's, based on the row tag there in the window, there's 504 rows altogether. But if we just sort of scroll midway, we can see that the first 209 don't have a product model ID, and only about the last 300 or so actually have a product model ID. So, of the products, only 300 or so have a product model ID. Let's look at product model. So we've got 129. Now I will point out, in your copy, the standard copy of EdventureWorks, there are actually only 128 product models. I've actually created one myself, number 129, purely to demonstrate what happens when you've got a value in product model that's not in product. So you won't see this, I do, and I'm just doing this purely to demonstrate what happens when there's data in one table and not in the other. Okay, so product model that's not in the product table. So let's come back to our inner join query, and we'll just run that again. Now what are we seeing? In terms of the total number of rows, we're only getting 295 returned. So of all the products, we're only getting 295 rows because that was what we saw before. Only about 300 or so actually had a model ID. So because the ones that had no model ID, they had null in it, they don't get returned because it's an inner join. Now similarly with the product models, and bear in mind we are ordering this set by the product model table and its product model ID prime key, we're only returning them up to 128. The 129th, the one that I created myself, which does not exist in the product table, that's not getting returned because it doesn't satisfy the inner join. With an inner join, for a row to be returned, the joining data has got to be in both sides, in the right-hand table and in the left-hand table. If you're not in here or you're not in here, you don't get returned and a row will not be created for you. So now let's look at how a left join works. Now the left join, we return everything in the left-hand table, whether it matches or not. So in this case, we've got the same records matching with product, with the model table. That one matches, that one matches, that one matches. That one does not match because it's got a null, but that's going to get returned anyway. So let's see how it works out in the results. Well, the left join results are a little bit wider. We've now got 4 rows, and we've got 4 rows because the product record that didn't have a model and did not match the join, that gets returned anyway. So as a minimum, you're going to get all the rows in the left-hand table, every single one of them, literally the entire table, and you will get the matches on the other side. And you're probably wondering, well, hang on, this has got to be returned as a grid, as an even grid, like a spreadsheet in the results. So if that one doesn't match, what's on the right-hand side? Well, what's on the right-hand side is a whole bunch of nulls. It's just a whole row of nothing but nulls, everything including the prime key. So let's apply what we've learned about left joins to our little join query here. So I'm going to change the inner to a left and execute it and see what happens. Right, what have we got? We have got 504 rows as opposed to the 295 that were returned before. So basically, we're returning the entire 504 rows out of the product table. There's the product ID, the name, all 504 of them, including the ones that had a null product model ID in the product table. And if we look in the rows selected from the model table, we've got, these are the ones that failed to join. These are the rows that failed to join. And in the columns for the model table, the right-hand side of the join, we just get a flat null. But in the product model rows that did satisfy the join, of course, we do get the product model data. Now we come to right join matching. And I think you can guess what's going to happen here. In the right join, we return absolutely everything that's in the right-hand table. Everything gets returned there, nobody misses out. And we only return the rows from the left-hand table if they match. So this matches, this matches, this matches. This 23 model doesn't match, but it's going to get returned anyway. And this 788 product that doesn't match because it doesn't have a model, that does not get returned. So what is that going to look like in the results? So as you can probably guess, the right join is kind of a mirror flip with respect to the left join. So we get everything in the model table, the right-hand table, including the one record that didn't match, the 23. We don't get any product records that failed the match. So when this is represented in a grid form, on this row, because this has nothing to match with, we just get a whole row of nulls. So let's see this in action in our query. I'm going to change that to a right join. And just to make things display a little bit, help it make a bit more sense, I'm going to order it by the product model's prime key. So I'm going to change that to PM, the alias for product model table. And we'll execute that and we'll see what happens. Right, what have we got there? There is the columns from the product model table. There's the product model's prime key. And if we scroll down, we're seeing that repeated 3 times because it's matching 3 times with the product model table. We'll scroll down, scroll down, scroll down, scroll down, scroll down, scroll down. Now note, these particular models are returned even though they are not in the product table, because it's a right join. Whatever's on the right-hand side, that gets returned at least once, and because it's got nothing to match with on the left-hand table, in the left-hand table columns, we just get a row of nulls. But interestingly, if we go down the very bottom, and we go down here to the little one that I created, so Mike's dummy model, which we absolutely know for a fact does not exist in the product model table, that gets returned. And because it does not match with anything in the product table, in the columns for product, that just returns a whole bunch of nulls. Now, I'm going to let you in on a little secret. And I'm going to give you the benefit of my 20 years experience in working with databases and working with SQL. In my 20 years, I have never used a right join in my life. Never used a right join ever. I'm really only showing you this to make you aware of its existence and to make the course complete. But it's really redundant when you think about it. I mean, all a right join is a mirror version of a left join. So if I ever wanted to, for example, do a query where I wanted all the models and only the products that match, all I would do is just put the model on the left-hand side and do a left join, something like this. And hey presto, this is our right join that's been turned into a left, simply by, when we write it, put the model table on the left hand side, the product on the right hand side, and then turn it into a left. And the benefit is you only have to mentally remember two types of joins, inner and left, and that's all you need to get what you want. So let's try and turn our little fancy right, just to prove my point. We'll go back to Management Studio and turn the right join into a left and see what happens to the result set. Okay, so here's our convoluted right join. So tell you what I'm going to do. I'm going to take product model. I'm going to put it up here. I'm going to take the product. I'm going to put it down here. And I'm going to turn that into a left. Now, in the old query, we had 305 rows returned. Let's see what happens now. Right, we've got a whole bunch of rows, 305 returned, and if you were to examine the two record sets, you would find them identical. Now, my point is, if you do it this way, you only have to remember about inner joins, left joins, and you don't have to remember anything or ever use a right join, which is a bit, you don't have to do that mental gymnastics of flipping things. So inner join, left, and in practice that will get you what you want. So let's recap everything we've learned, and it has been a very long lesson. We learned about joins and the ability to draw data from multiple tables. We learned about inner joins and left joins. We also learned about right joins, but in practice I have never actually really used these because you can just do a left join and just swap the tables around.